Jazakallah for making my life so much easier. By not making my life so much easier.
Now I'm not inviting you.
Look at you, what a bitch. You can't play with my ball. Give my back, give my ball, I'm going home. Hey, just like one of them.
Did you hear about the Fair and Lovely? Are you out of the thingy? Did you?
I was thinking of leaving. I just
Nah,
turned
don't
outside.
do. Just turn yourself.
Ridiculous. Fair and lovely, fair and handsome, what a dick.
You know about Fair and Lovely?
Yeah.
Oh my god.
Mobiling jazz.
Oh my god. I had a guy in year 10 he was in India.
Isn't it Dove Fair and Lovely?
No. Are you dumb? Fair and Lovely is cheap shit, man. It's like you get it for 5 rupees or something.
Dick.
You break that thing. Where is that guy gone? Okay, let's.
Little podge.
But I haven't seen anybody who's actually managed to actually show why that is the case.
Just 1 times
So
30 plus 30.
look at the structure and think what's happening. Potentially there's a reaction here. There can be one there, and one there. So it's 3 vertical reactions. Here's a fixed support, so that can carry a moment as well. So in terms of reactions on there could be 1, 2, 3, 4. So taking moments about here, that's not going to help a lot. Taking them about there, you're still going to get stuck. And the same over there. So it needs something more than that. Well, if you look at the structure, if that load is 1 down there, that means we must have tension in that cable up there. Okay? If we have a look at C, we've got something like this happening. And imagine that's our point B down there. So if you drew yourself a 3-body diagram around there, through B, up like that, that's what we're going to have. This, you can see we've got a force in that. Now if you take moments about B, we should be able to find B. And it would be the horizontal component of that times that height, plus the horizontal component of that times that height, horizontal component of that times that height, and the horizontal component of that times that height. And that would actually give you MB. So you don't need to work out the reactions. Free body diagram through B should be sufficient, as long as we can find the forces in all those cables there. And that height was 60 meters. So, you could work that one out, I guess. It's just a question of resolving vertically. What about now the force in CG? So we know that one. How can we find the force in that number?
I can't be any vertical force because the vent at the bottom is horizontal.
Exactly. The force in this one has to be 0, because if there was a force in it and you resolve vertically, there's nothing to balance it. So you're right, that one is 0, and by the same logic, that and that is 0 as well. So the moment we want will be the horizontal component of that force times that distance there. What do I call that? H. MB is just equal to H times 60. Now what's H? Well, if you resolve vertically, you'll get the force in that number there. And then if you resolve it horizontally, you'll get the horizontal component of it. So you could do that. But if you just look there, the angle there is 45 degrees. 30, 30, 60 high. So the horizontal and vertical components of the force in that member are the same. Vertical one is 1. So without any calculation, you can say that H is equal to 1. So our value of MV is 1 times 60 kilonewton meters. Say, no calculation, you only calculators. The numbers are picked to make it easy for you. But what you have to do is be able to understand the way the structure works. Okay. Then you want to go back over that, or?
How does that then relate to the influence line in CJ?
Oh, well, we've got to do that one differently now. It'll be a different shape. Okay, so is everybody happy with that? Good. Okay, so I'm going to rub this one out and draw it up there. Say I'm going to draw the whole thing. One thing that perhaps somebody's coursework up here, so apologies for that. But just coming back to this shape, supposing that triangle, not quite the right side, but it reflects the triangle up there. What we've tried to do with this is do that. So what I've done...
He's going to have a compressive force.
He's ripped some forces.
Then I've just linked up shape back to the known place. So in your mind's eye, that's what you really perhaps need to think of. So sometimes with these problems, just getting a bit of paper, twisting it around can help.
I like what you do.
Okay, so suppose we have a go now at
Quality. Look at the size. Megabytes. 1,000 megabytes.
It is quite a decent quality.
What?
It is quite a decent quality.
At least you have the big screen, the HD TV. HD TV.
I need to get one.
Told
A HD TV, what?
MashaAllah, very nice 52-inch HD Shaitan, eh? You staying there?
Oh, nice weather.
Nice weather. There's barely any windows here. It's come back.
now you imagine
None of you have a nice way to
it's great.
No.
nasty. Popping eyes with
That's what I miss. Blackburn.
And we do that. So what's going to happen now to this line there? Well, even for this one, you should be able to say the influence line has to pass through here, through there, and through there, because those are all support points. If we'd asked you for the influence line, let's say for the reaction at E, you wouldn't have been able to say that, because then we'd be breaking the structure at E and actually moving it upwards, so it wouldn't pass through the 0 there. CJ, we haven't destroyed any of the supports. So just the question now, what happens to that bottom line? If you can come up with the shape, just have a look at it and think about it and think, supposing I put the unit load wherever the maximum is, would I expect that to be the case? If you put it somewhere else, would you expect what the influence line is showing you to tell you about the force? So you can often come up with the shape quite quickly, and then just allow yourself a few minutes to look at it and think, could it actually be right? And if you break it and you pull down and you push it. Next, we're really interested. You have to start with what
between D and G.
So it will
J
break.
and A,
It'll
something
break.
would happen.
It'll break, so over here, you can have a point over here.
we'll take that off. So you've got to get the shape. this one.
I know that's gonna be 1 sine 45.
Don't think about the numbers now.
And then that's also gonna be 1 sine 45.
How come you got two B's?
There we go. Possibly.
Yeah. I think because
No.
a B
No,
at center
no,
is going to be 0.
No, yes.
At center is
What?
going to be 0. So
What?
you carry on further.
That's 1, 0, 0.
Yeah, that's what I mean.
That.
I'm not going to draw it, but let's do it for him. How is Blackbird?
The Upneys, you know how brains are so funny. I was at Bolton train station,
Are you in the vehicle?
Gandhi Upneys came
I
and
know,
sat down
that's
next to me. I was just like, just on my phone,
The
yeah.
funny thing is, them
No,
I think
listen.
they're like, कोई बहुत ऊंचे level पे हो.
But you know, it was so funny, right? It's so stupid, it's unbelievable. Guess what they said, right?
उर्दू
They-
में फिर क्या हुआ?
बस ऐसे ही बात कर रहे थे इसने मुझे टेक्स्ट किया था ईद पर
know.
लेकिन यही उसका नंबर है
They do that on purpose. They do that on purpose, I swear. I had a friend with me. Listen. I had a friend with me. Oh, so what are you doing at university? Oh, alhamdulillah, I'm doing psychology and so how are you doing with it? How you get it? Oh, mashallah, I'm on the first. Inshallah, I'm looking to get a good job as well at the end of it. You know how it is, so tough, but you know if you got first, it's okay. You know, it kind of works out, right? And a guy with me, he's a nasty bastard. He goes, oh my God, I mean, people these days they talk about first as if they can get it. You see, you can tell they're bullshit. He was saying that in front of me. Oh my God. He was.
I know you told me.
Crazy.
You
I was embarrassed. I had to say
know.
sorry to her. Look, I'm sorry. Like this guy is crazy. But I wasn't thinking anything like that. You can tell. She stopped talking.
That's
to her.
Zubair.
No, it wasn't Zubair.
Is it anything close to that?
No.
Nothing whatsoever.
Well,
Does that then go downwards?
You're on the right lines.
I mean,
This one.
would that then go downwards?
Just ask yourself. You've got that. Fair
Yeah.
enough. Now you want to do it right. Okay, so let's look at this bit here. Suppose we put the unit over there. Would you expect the force in the unit?
Yeah, 1 sine 45.
So that's it. Put it there.
No.
Put it there.
No.
Put it here. Right? Now, would you expect there to be a force in that number?
No, you would, because if you have a tension force there, then that horizontal component has to be sort of counted by that horizontal component. Alright.
Supposing you say that, so you're going to say that's in tension as well.
Yeah, so I mean, if one has to be in tension, there has to be a horizontal component sort of countering that. So
But then if
So
one
this
is
joint
tension.
here, if you resolve vertically,
Alright, yeah, you have. So then how would you resolve that?
I've just taken you a little bit of the way. Now you're going to think what that is. So that can't be right.
Yeah.
It has to be downwards.
No, it has to be 0.
Yeah, because. Yeah.
So what happens to the load you've talked about?
Yeah,
Just
so
think
what
about
happens to that horizontally? How does that happen then? Because look, he says you put one there, yeah, so then that one becomes intention.
No,
What
he
happens to
says every time you're moving along, it's related to that. You have to think about what the force is in there. So when you're moving, like you said.
No, but what I'm saying is like think about this way. If we put a tension force there, yeah, right? If we put a
Unit
if
load.
we move, yeah, if the unit load moves there,
Yeah.
then that one becomes tension, right? So if you want to resolve at that joint, resolve forces at that joint, right? Then how is that load counted? Because that has to be in equilibrium, otherwise it's going to all go.
Yeah, I know. But he said about
but if you
but
do
he
that-
said about vertical, resolving it vertically then.
Yeah, but then if you come down here and you solve that vertically, then there's an upward force there, and that has to be countered by something, and it's not being countered by anything.
Exactly.
No internal force, tension.
No, it's zero.
Yeah, so basically over here, all the way I think, it'll be zero. It'll be zero from here.
So where is that counted by? Yeah, it might be. What's it counted by? That's what I'm thinking. I'll ask you. I wish you could just do virtual work in the exam, just not do anything. It's like, it's all in my head. It's all, absolutely 100% all the time.
I know.
It's all in my head. It's all in my head. Said that to after this day, so I think just hoping to the highways exam, see what you get. He goes, they might put you down, they might give you the worst marks. The worst mark counts. Well, or they might average you out and use that as an average. I'll go and put some bullshit name like John Smith or something. And just try it and see what happens. Let's go back and ask. That John Smith, what mark did he get?
I
was John Smith. 80% I was John Smith.
Through there. Now here we've got a triangle, there we've got a triangle, there we've got a triangle. So this triangle here, if that goes up, that can't move relative to its current position because it's held there by that shape. So that would seem to say that we have to come back to that point in there.
I think you got it the first time.
So that's the what happens to this bit up here? Okay. Because that's
There's nothing, zero.
Over that bit. So should we get
No, it's not.
happening there?
You need to balance this
Pulling
force
that
now.
way, so that's the equivalent of a pull that way and a pull that way. This one goes straight down, so we don't need to worry about it. But if we pull that way, would you expect this to go up?
Down.
So if it goes up, it could look something like that. Several people have got something, it's not quite the same as this, it's virtually the same as it.
I told you zero.
Load here at J, do you expect a force in that member? Yes, just resolving vertically.
That's how I think.
So that looks encouraging.
Just move the unit load along.
If we put the unit load here, do you expect a force in that
unit
member?
load at A.
Take things
B,
off the
sorry.
from last time.
Just go
Do
directly
you
down.
expect a force in that member? Well, if that's down there, yes, you will get forces there and there. Something's got to balance them horizontally. Could be that. If it is that, and we look at this joint, can we rationalise? So for this to be true, there's got to be a tension force in that member. If you look at that joint and resolve vertically, there's nothing to balance it, so that would have to be zero. So we're not right with that. I don't think there's anything wrong with coming up with a shape perhaps like that in that logic, as long as you go back and examine it.
It should be out down. It should be off.
That represents our influence.
Is that it?
To balance it, yeah.
Balances that. It certainly has to be one at the top. Where does it go?
To instead of fixed end?
It doesn't go down there. It doesn't go down there.
It goes in the middle.
It's a reaction
B.
force.
It goes into the tower.
The B.
The tower can resist bending.
That's what I said.
cantilever, so that horizontal force there creates a moment in the tower, which is what we saw anyway with the earlier influence line. So that's what it is. So now one just needs the value.
Sine 45.
Sine 45 times 60.
No, it's
Two
just
something.
sine 45. Because it's only tension, it's not.
Root 2, yeah.
So that's that. Another way of thinking of it is, if you just look at the structure, to get a force in this member here, the only way that can happen is if there's something here at J. But if there isn't, we've got nothing to balance it. So if we stick the unit load, let's say, in there, some of it gets carried over there, some of it's transmitted to J. So that's okay. If we put the unit load in there, some of it goes to H, but some of it comes to J. So we're okay on that. If we stick the unit load, let's say, over there, then some of it comes to A, some of it comes to H, but nothing goes to J. So with a load anywhere between there and there, we've got to have the zero, which is what we've shown. So what we're trying to do here is, as well as come up with the shape, the value, just think about the way the structure behaves.
Apart
For all
from
design
this,
structures, the analysis has to be done, is the tedious bit, certainly isn't the fun
apart
bit.
from question part.
It's the creative side of structures, designing them. And for that you really have to think of ways in which you can make them work and carry loads.
Why is it root 2?
Understanding this behavior
Why is it root 2?
Because
Sine 45.
T is the tension in the thingy. T sine 45 is equal to 1.
covers that. If you wanted to have a go on one more, we're going to have a break now. But if you like to think of the reaction at A. So, you don't want a break.
What is root
1
2?
times sine 45. This is because if you have a vertical force going downwards there, right? And then that's going to be, sorry, if that's 1 sine 45.
Stop now for 10 minutes.
Yeah, sorry, if that's 1, then that's 1 sine 45. Yeah, T. So I mean, no. So what he's saying is if there's a point load at J of 1, then what's the tension in that member? Obviously that angle is 45. Because it's 60. So that angle is 45. So that's going to be 1 sine 45. That's what it is. It just shows the love of motion of how that works. Because that joint is in equilibrium. Get it, right? Whoa. Easy, Kizel. Good.